Welcome to Maths for All. I'm Aisling Flynn. This is measure 1.3, area. We give the letter A to area, and area is, or the area of a shape is how much surface it covers. It is two-dimensional, or 2D, and it is flat. It's measured in meters squared, centimeters squared, etc. To calculate the area of a shape, we must multiply two of its dimensions, for example, length by width. Let's consider this rectangle. It's made up of 1 by 1 squares. The last time we looked at its perimeter, so it was 3 on the side, 5 on the top, 3 and 5. Okay, but to look at its area, we can do two things. We could count individually how many squares there are. Okay, so there's 15, 1 by 1, so 15 is the area. Or we can count in groups. So if we count in columns, there's one group of 3, 1, 3, 2, 3 is 6, 9, 12, 15. Okay, so groups of 3, there are 5 of them. So we can use multiplication. We can say 3 times 5. Because the measurements are 1 by 1, possibly centimeters by centimeters, will give, that's where centimeters squared comes from as units. Okay, so quadrilaterals, we just saw an example there. Squares, we can get the area of a square by multiplying its length by a width, like the previous slide. We know that squares have the same length and same width. So this one is 9 times 9, we get area 81. Rectangles, again, area is length by width. This example is 12 times 5. Okay, so the area of that is 60. Parallelograms. Okay, the area of parallelogram is not 10 by 6. That would give a rectangle which would be straight up, so the sides would be vertical. When the parallelogram becomes sloped, or you take the rectangle and you stretch it, the area is reduced. Okay, so it will be a smaller area than a rectangle of the same dimensions. The formula for the area of a parallelogram is a length, so that's one side, by the perpendicular height. So that new symbol there looks like an upside down T, means perpendicular, and perpendicular means at right angle, so when two lines meet at 90 degrees. Okay, so if we look at our picture here, the 10 on the top or the 10 on the bottom is going to be my length, and the perpendicular height will be the height straight up and down from those, meeting them at 90 degrees, and this one gives the measurement as 5, so that's what you use, not the 6. So 10 5s are 50, that's the area there. If you look to your formula tables book, which is provided for your exam, you'll find information on the parallelogram there. Okay, so you don't have to remember this as such, but it does look slightly different. Here's area. Area equals AH. Okay, where A is shown here as a baseline, and H is the height straight up. Okay. Triangles. Let's start with the rectangle here. We know from the previous slide that the area is length by width. Just for our purposes here, I'm going to change the names of those measurements to base by perpendicular height. So let's take the length as being the base and the width as the perpendicular height. Okay, now let's cut this rectangle in two, and it's divided into two equal halves. What have we created but two equal triangles? Okay, and the area of one of those triangles is equal to half of that of the rectangle we just had. So the area of a triangle is half the base by the perpendicular height. And the bases here are the black lines, and the height are the lines, the black lines meeting them at 90 degrees. So we don't use the red line at all. That's not perpendicular to either. The same is true for any triangle that's made out of that same rectangle, okay, that triangle there has the same area as the others. You use half the base by the perpendicular height, and indeed a triangle like this has the same area as well, okay? So here's my base, okay, but the perpendicular height must be measured externally or outside, okay? So you continue whatever you're using as a base, and you draw a perpendicular line up to the highest point, and that will give you the perpendicular height. It's going to be the same height as the original rectangle, okay? Now let's get the area of this triangle, okay? Firstly, we have measurements of 10, that's a base, but 13 is not perpendicular. We need that perpendicular height that's shown there, the line that's straight up vertical. Okay, we need that perpendicular height, and we're going to use Pythagoras' theorem to get it. We're going to focus on 1/2 of the triangle, okay, and that contains a right angle. Okay, so instead of 10, I'm using 5. So we're only going to use, let's say, the right hand side. So that's 5. B, I'm going to call H for height, perpendicular height. And 13 is a hypotenuse. Okay, so we can use Pythagoras' theorem to solve that. When you work out all the numbers, that height is 12. Now, once you have that, you can use your area of the triangle formula. Your base will be the full 10 and the height is 12. So you get A is half 10 by 12. You could say A is half of 120, which is 60, or half of 10 is 5 times 12 is also 60, okay? Or you can use 0.5 instead of the half on your calculator. There's information on the triangle in your formula books as well. Here it is. Area you see here is half AH. A is this baseline, and H is the perpendicular height there. Okay, circles. And we have a formula for the area of a circle. It's pi r squared. Okay, so you're using 2 dimensions, r by r. Okay, and your area will be in whatever, centimeters squared, etc. Okay, let's calculate the area of this circle. Write down your formula for the examiner, and we'll use 3.14 for pi, and r squared will be 5 squared, or 5 by 5. And I get 78.5 centimeters squared. Okay, and again, in the formula books, you'll find a circle or a disc. There's the formula we had yesterday for circumference or perimeter. And here's the formula for the area of a disc. Make sure you choose the correct one, pi r squared. Okay. Right, compound shapes. What is the area of the shape below? Give your answer correct to the nearest whole number. So here's the kind of pencil shape we had in the previous lesson. Okay, we're going to have to take it in 3 sections. We have 3 shapes: a semicircle, a rectangle, and a triangle. So the semicircle is half of a full circle. Let's calculate the area of the circle. And remember, we're using radius. That 6 marked on the diagram is a diameter. So our radius will be half of that, which is 3. So area will be pi, 3.14, by 3 by 3. So 3 squared, you get 28.26. But this is the answer for a full circle. So for the semicircle, we must divide it by 2. We get 14.13. Okay, the next part is the rectangle. Straightforward, length by width. 6 times 12 is 72. And the third part is the triangle. Okay, so there's our formula, half the base by the height. So what to use for base and height? So you can use this line here as your base. Okay, and we know that is 6. Why would you choose that? Well, because you have 10 here. which is perpendicular to it. So that's your perpendicular height. So half of 6 by 10 is half of 60, which is 30. And then to get the full shape, or the full area of the full shape, you add your 3 individual answers together, and writing your answer to the nearest whole number, you should get 116. Okay. Now, compound shapes, another one. What is the area of the shape below? So we use this shape in perimeter also, but let's look. Okay, we must break these shapes up into shapes we know how to calculate. That is rectangles. So we need to cut this shape up into rectangles to do our calculations. And depending on how you picture this diagram, okay, you might use subtraction or addition. I think this particular one, subtraction is the way to go given the measurements. So you could calculate the area of one big rectangle, so 16 by 18, and then subtract the area of a small rectangle, which is equal to this grey one, which is cut out in the diagram. So that's to use subtraction. Calculate the big area and then minus the little one. Or you could calculate this one here, but I don't think we have enough measurements. Oh, we do. It would be 16 by 15 for this white rectangle, and then add the 2 grey parts here and here. So depending how you envisage it first when you see it on an exam, that's what you go for, provided you have enough measurements. So I'm not going to answer that one. Perhaps you take some time to work that one out yourself. Okay, you do it now. Try the quiz and your written exercise. It's a small glossary.